we knew that the equation of a line in 2 dimensions is actually pretty simple. If I have a line in 2D, the general form for the equation of this line is going to be ax plus by plus c equal to 0. In higher dimension, the equations of a line is also not going to be very complicated. So let me start off in 3 dimensions. Let's say I have this point Q. The coordinate of this point is going to be x0, y0, c0. And I want a line that passes through this point Q and is parallel to the vector v, whose coordinate is ABC. So if I were to draw like some kind of picture, I have a 3D axis. I have a point Q. The coordinate of this guy is going to be x0, y0, and then c0. And I have another vector v. So this is my vector v. The coordinate at the endpoint of this vector is going to be c. Well, it's not hard to imagine if I want a line that is parallel to this vector v and pass through q, it's going to look something like this. And one way you can think of this line is that I can imagine starting off at my point Q here, and I add a multiple of a vector v to my point Q. So if I add a multiple of v to my point Q, I'll get something like this. My vector will all remains on the pink line, which is the line that I want. I can also do the negative multiple. It will go in the opposite direction, but it will always remain on the pink line that I want. So, if we think about it, I want to add a multiple of v to a point Q. A multiple of v looks something like this. I have the coordinate of v is ABC. I multiply this by a scalar t, and I add that to I add this vector to the point Q. The coordinate for Q is going to be x0. Okay, let me kind of move a little bit. It's going to be x0, y0, and then c0. So here, I add a multiple of my vector v to my point Q. So let me actually kind of write this down. This is my vector v, and this is my point Q. So this would give us the vector equation of the line that I want, and this in fact is what we are looking at here. The equation of a line that passes through point Q and is parallel to vector v is just q plus vt. Now then, I can also write this thing in parametric equations. So I look at the x coordinate, the y coordinate, and the c coordinate separately. If I were to do that, let's kind of see. The x coordinate is going to be x0 plus at, x0 plus at. The y coordinate is going to be y0 plus bt, y0 plus bt. And the c coordinate is going to be c0 plus ct, c0 plus ct. So this is the coordinate of the xyz point on my line, and this corresponds precisely to the parametric equation that I have here. My x coordinate is going to be x0 plus at. My y coordinate is going to be y0 plus bt. My c coordinate is going to be c0 plus ct, and you can see that they can be easily arrived from the vector equation. Now then, let me actually show you another way you can think of this whole vector, this whole parametric equation things. So let's kind of go back to the original graph that we have. I have my point Q, and I have a vector v, and I want this pink line. I want the pink line to be parallel to the vector v here. So what that means is that if I have a point on this pink line, let's say the coordinate of this point is xyz. Now then, if I compute this vector, my orange vector has to be parallel to the green vector. But what is the what is this orange vector? This orange vector, because the coordinate of my Q is x0, y0, c0. So my orange vector is actually just x minus x0, and then y minus y0, and then c minus c0. So here goes my orange vector. My orange vector has to be parallel to the green vector. So that means my orange vector is a multiple of the green vector. But my green vector is just ABC. So I knew this guy has to be a multiple of ABC. So it's just ABC times some constant t. So this is also another way that I can think of the green line that we have. And if I were to simplify it, I'm actually going to get, let's see, I'm going to get my, so this, my left hand side, this is the same as x, y, c minus x naught, y naught, c naught equals to ABC. So let me actually use the same color for whatever reason. So that equals to ABC times t. And if I were to move this guy to the other side, I'm gonna get x, y, c equal x naught, y naught, c naught plus ABC times t. And this is the kind of the original equation that we have to begin with. So here's another way you can think of the line in 3D space. Now let me also talk about a line in higher dimensional space real quick. It's not going to be much more complicated. Let's say I have a point in whatever dimensions, and I want a line that passes through this point and is parallel to a vector v. So basically, the equation of this line here is going to be just q plus vt. So generally, this equation holds in higher dimension as well. So for now, let's actually just take a look at the example that we have down here. I'd like to find an equation of the line that passes through the point 1, 2, 3, and 4, 5, 6. So I have 2 points, 1, 2, 3, and 4, 5, 6. I want a line that goes through this 2 point. Now, one way we can look at this line is that I can think of it as a line that passes through 1, 2, 3, and the dimension of this line is parallel to the green vector here, which is the vector that starts at 1, 2, 3 and ends at 4, 5, 6. What is the coordinate of this green vector? Well, this green vector, the coordinate of this guy is going to be just 4 minus 1, which is 3, 5 minus 2, which is 3, and 6 minus 3, which is 3. So, I'm looking at a line that starts off at 1, 2, 3, and is parallel to 3, 3, 3. And we knew this vector is going to be, this line is going to be just 1, 2, 3, plus 3, 3, 3, times t. So this is the vector equation of the lines that I want. Also, I can do the parametric equations for this. It's going to be just my x is 1 plus 3t. So this is just pulling the first coordinate of the vector that we have above. My y is going to be just 2 plus 3t, and then my c is going to be just 3 plus 3t. Okay. Now let me actually also show you a few more other ways that we can achieve the same thing. Let's just say, how about if I actually think of this line as starting off at the point, at the point 4, 5, 6, and the direction of my vector is actually in the opposite direction. So I'm looking for a line that passes through 4, 5, 6 and is parallel to my green vector here. So what's going to happen in this case is that my green vector is now going to be negative 3, negative 3, negative 3. And the equation of the pink line in this case is going to be 4, 5, 6 plus a multiple of negative 3, negative 3, negative 3, and then t. So this thing is actually another form for the equation of, it's actually another vector equation of the same line that we have here. So there's actually more than one way to write the equation of a line. So this guy and this guy are the same thing. Now, if this is not enough, I can actually show you another way that we can draw this same line. So let me actually do that. My first point, this is 1, 2, 3. My second point is 4, 5, 6. And I'm looking for the equation of this pink line here. Now then, how do I identify the points that lies on this pink line? Well, if I have a point that lies on this pink line, let's say I have this guy and the coordinate of this guy is x, y, and z. What needs to happen in this case is that I'm going to need the vector from 1, 2, 3 that ends at the x, y, z. So my black vector here. And I'm going to want this black vector to be parallel to another vector that starts off at 4, 5, 6 and ends at x, y, z. So for x, y, z to lie on the pink line, I'm going to need my orange vector to be parallel to the black vector. This is the only way to guarantee that my point x, y, z lies on this pink line. So what is my black vector? The black vector is going to be x minus 1, y minus 2, and then z minus 3. And then how about my orange vector? The equation for my orange vector, I mean well, I guess I can say equation. Well, not equation, the coordinate of my orange vector, my orange vector is going to be x minus 4, y minus 5, y minus 5, and then z minus 6. So here I have the equation for my black vector and also the equation for my orange vector. And I said earlier that for my blue point here to lie on the pink line, I'm going to need the orange vector to be a multiple of the black vector here. So what essentially ends up need to happen is that this orange line has to, this orange coordinate, this orange vector has to equal to the black vector times a constant t. So I'm gonna have this equation x minus 4, y minus 5, z minus 6 equals to x minus 1, y minus 2, z minus 3 times t. So this, once again, this is another form for the same lines that we are looking for.